Welcome to NHERI SimCenter's Live Expert Tips. In this session, we will introduce new Geographical Information System functionality that's been incorporated into the Regional Resilience Determination Tool, or R2D tool, and show how it can be leveraged in a regional analysis workflow. Our presenter today is Dr. Stevan Gavrilovic, who is a postdoctoral researcher at the NHERI SimCenter and headquartered at UC Berkeley. He received his Ph.D. and master's degree in civil engineering from the University of British Columbia and his bachelor's in civil engineering at the British Columbia Institute of Technology. His research interests include software development, nonlinear finite element analysis, and structural damage modeling. Stevan, thank you very much for being here, and I invite you to begin.
Thank you, Matt, and thanks to everyone who came to my presentation today. So today my talk will focus on regional analysis, particularly how we can visualize the results. One thing I'll touch upon is how to set up one of these large analyses to run remotely. So a little bit about R2D. It's a multi-asset, multi-hazard tool. So currently we have support for import and analysis of buildings, but very soon we'll have lifelines such as pipes, roadways, so on. And currently we support earthquake and hurricanes. Outline of today's presentation. I'm first going to show how to set up a regional analysis to officially run on the DesignSafe HPC. R2D can run jobs both locally, so on your local computer, but when you're talking about regional analysis with tens of thousands of millions of buildings, then we've got to rely on cloud computing to handle those types of workloads. Finally, assuming we get the results we want, I'll go over some functionality currently in R2D and how we can post-process those results in various ways. And we have QGIS functionality, which many of you might be acquainted with or have used. And most of the core functionality of QGIS is incorporated into R2D. So this is something I will go through. Some resources for today is you could view and download the different example files, both through the R2D GUI, which I will show, and also through GitHub at this link right here. You could also access the tool's webpage at this link. A little bit is shown down here. At this website, you could download the app, go straight to the documentation, which is in this link, or join us at the forum. Now, R2D is open source, so all of our code is sitting in the SimCenter R2D tool repo. So you can go check that out if you're interested. And finally, to run some of these remote analyses on the DesignSafe, you'll need a DesignSafe account, which is free, and you can go and register right here. So this is what you see when you start R2D. This is the main GIS pane, which allows you to manipulate and zoom in and out on this map. I'm just going to provide a quick overview now, and I'll show everything in a live demonstration, so don't worry. This is the layers pane on the left here, so every layer that gets imported, such as a hazard or the buildings, will appear here and also show in the map. And finally, on the left is this ribbon. It's called the SimCenter App Selection ribbon. So you can go through each one and set the input parameters for the different types of analyses you want to run. Now, I'm not going to talk about each and every pane here. There's another video on the SimCenter website where you can go and watch, where I walk through them in detail. I'm going to show you how you could set up analysis, click run, and then post-process the results. How you could run the analyses, well, that's at the bottom here. Each button here corresponds to a different method of running or getting information. So run will run it locally on your computer. So if you have 10,000 buildings, you want to click this one. If you have a lot of buildings, then you want to click this one. This is run a DesignSafe, and a pop-up will come up, which I'll go over, allowing you to input different types of different information, different parameters to get this thing to efficiently run on the remote computer. Finally, when that's done, you can go eat your sandwich, get some coffee, and then click on the Get from DesignSafe button to automatically download the results from the cloud and show them in R2D again. At the bottom here is the program output pane, where all the text will show if you're running this analysis locally, or it'll tell you the different steps or different sequences that are happening when you submit the job or when you get the job or recover the job from the cloud. Here's kind of an overview of what QGIS functionality is available in R2D. So not all functionality is available. This is so the program size can remain reasonable. I think the QGIS distribution is about 3 gigabytes in size, while R2D is about a third of that. But most of the core functionality, I'd say the important functionality is here. And also, if you need those advanced features in QGIS, you could export what you have from R2D. QGIS is also no cost. You can download it, install it, do with the results as you see fit on QGIS, and then bring them back into R2D again. So there is the ability in R2D to export the results into different GIS formats that are universally acceptable across the industry. You could use it in your Python notebook or other GIS applications out there. I'm going to talk about how to run a job remotely. We've had some questions about this, so I'll just touch upon it briefly here so you could go off and run your own large-scale analyses. And what I'm saying here is also in the documentation as well. So when you click on the Run on DesignSafe button I showed in the previous slide, you will see this pop up here. And this is where the user specifies how much computing resources they will need and other various input parameters that will control how the analyses are distributed on the HPC, and by HPC I mean high performance computer. So when specifying these input values, you will need a rough idea of the memory requirements of your analysis and also the computational requirements. So in other words, how long will the analysis take and how complicated are my models? So those are the two questions you should have in mind. And I'll use a quick example to go over the best practices. So one thing I should mention is all the jobs are run in parallel, or what's called embarrassingly parallel. So you have these HPC nodes, and each nodes will have several cores, which can have several threads. And all these threads run things simultaneously in parallel. So for example, if you have 10 nodes and 48 threads, which is dependent on the computer architecture, I think 48 is the maximum number of threads, you'll have 480 analyses running in parallel. But you have to be careful here. There's another, we have to be careful because we don't want to overload the cache. So each of these cores has a memory cache. And if you have a very complicated model, like say a finite element model of some hospital, you don't want to put 48 of those models, 48 of those tasks on one node accessing the same cache, and your performance will degrade substantially. So you want to make sure your computing loads are spread out evenly across the cores and across the threads. And then there's this number of buildings per task. So it takes time to also load buildings to a task. And this will let you load a batch of say 10 buildings to one task. Now you got to be careful here. If you reserve, say you have 100 assets, you reserve 10 nodes, and you have 100 buildings per task. Well, all the buildings are going to go to your first task, and then you're going to have 9 nodes sitting idle. So you want to use some judgment, figure out how many assets you have, how long will it take to analyze one asset, what's your memory requirements, and try to spread that out across the nodes and threads to get the most efficient use of HPC resources. So it does take some judgment. But at the end of the day, it allows you to perform really large scale analyses such as these. The remainder of the presentation, I will focus on example 1 in R2D. I will show how you could download that example from the GUI and quickly get going. So example 1 encompasses the northern part of San Francisco. We have a mix of buildings of various occupancy types, can be seen here. And we also, these buildings are subject to an IM field from a 7.2 event on the San Andreas Fault. So you have this grid, it's hard to see, but it's a grid of PGA, so peak ground acceleration intensity measures, spread across this region where the buildings get their hazard values from. In this case, over 15,800 buildings are analyzed for this one example. In the next few slides, I'm just going to quickly glance over some of the more important GIS functionality that we will see. And I'm going to get rid of the slides and fire up R2D for hands-on demonstration. So hopefully see me fumble around a bit, be more better than looking at slides. So to go over, we'll be looking at category-based renders. So how we could render things based on different categories, how we can render things based on a value, so say loss ratio, so that's called graduated value render, how we could filter the results. So if we want a loss ratio of over 35%, then we only see those. features or buildings, how we could link an external database to pull that information into what we already have, how we could visualize or plot some uncertainty, because R2D has uncertainty quantification algorithms in the back end. So we have some basic uncertainty measures that we can plot. And then how we can save the results for future use to use in other GIS platforms or your Python notebook or whatever. So to go over the category-based render, so this is when you want to differentiate between different assets, or sorry, between assets that can fall within several categories, like for example, occupancy type, structural type. Here I show those same buildings, but this time they're organized according to structural type. If I go a few slides back, you would have noticed that they're organized according to occupancy type. So that's what a category render does. Next, we have a graduated value render. And this is when you want to show differences in values using a range of colors or symbol sizes. For example, you want to use this when there's a numerical value, like a loss ratio, repair time, repair cost, that sort of thing. And here we have a loss ratio of almost 0 to about half, 0.5 across the region. And different colors representing, different shading, each colors representing the loss. Next, we have a rule-based render, and this is when you visualize the results according to set, really arbitrary set of rules that you'll define. For example, year built, loss ratio greater than 5, that sort of thing. And I'll show you how you can do that as well. So without further ado, I'm going to end the slideshow. So this is the GUI you see when you open up R2D. And in the middle here, we have our GIS pane, which allows the user to manipulate the visualization. So you could zoom in, you can zoom out, and you could pan the screen left and right by using just the buttons and the wheel on your mouse. And it may seem a little jittery on Zoom, but in person, it's a lot smoother. On the left here, we have our layer tree, as I mentioned before. So we have the different layers that are loaded, currently the buildings, the ground motion grid. And I could expand these layers to see other sub-layers. And in this case, there's selected buildings and all buildings. And here we also select base maps. So right now I'm showing the Google Road, but if I've loaded a few more, I could select and load others. But just to give you an idea of how that looks, I could switch between base maps. And I'm going to use Google Road because it stands out a little more. And before I go on, I'm going to show how you could download and load this example and run it on DesignSafe. And you can go up here to the examples menu in R2D. And in your just downloaded version or program of R2D, you won't have any examples preloaded. And what you'll have to do is you'll go to Manage Examples, select the ones you want, and then click on Update. And R2D will pull them from the internet, unpack them, and install them on your system. After which they will appear here in the examples menu, and you could click on that example and load it. And again, this is example 1, basic HASIS. I won't do that because we'll clear what I have here. But if you load an example, you can click Run on DesignSafe, send it off to the server. When the analysis is done, you can click on Get from DesignSafe. And this window will pop up. And in this case, it's an SF full job. And I could right click on it, retrieve the data, and DesignSafe will pull the data from the server. R2D will pull the data from the DesignSafe servers and automatically load it into R2D. And you'll see what I'm saying now. So moving forward, back to the layers, you have a selected building layer and an all buildings layer. The difference is you may want to only analyze a subset of buildings, maybe a city block, maybe a handful of them. In that case, you select those and they will appear in the selected buildings layer. I'm analyzing all buildings now, so I will turn this off and I will only pay attention to the selected buildings. If I double click on any one of these layers in the layer tree, which I'll do now, then I'm going to get the layer properties window that will pop up. And this just provides different types of information about the layer. And the one that we'll be concerned about today will be the Symbology tab. So how we can change the look of this layer to suit us. visualize the data how we want. You'll notice right now that it's using a graduated renderer, and it's graduating the loss ratio value. So this is simply a numerical value, the loss ratio from 0 to 1. And it's using a color ramp where yellow signifies very low losses and red is high losses, in this case about 0.5. So I'm going to close this and I'm going to duplicate this layer. So that's done by right-clicking on it and then selecting the duplicate layer item right here. And I could go back to the first one and rename it and call it loss ratio. I'm going to take this new layer and I'm going to rename it and I'm going to call it structural types. So to rename it, you right-click on it and then go to the rename layer item. Now I'm going to double-click on this layer again. And instead of a graduated renderer, I'm going to use the aforementioned categorized renderer. So when I click on that, it's going to ask me for what attribute do you want to categorize your layer, and I'm going to go down, no, not plan area, I'm going to go down to structure type. So I'm going to use a structural type, and I'm not going to use a color ramp. Instead, I'm going to use a random color map, and that's done by clicking on this little arrow here, and will allow you to select different types of gradients or color ramps, or create a new one, or just use a random one, which is the simplest. Now, when I click on the classify button right here, it's going to go through all the buildings and get the unique values for structure type. In this case, there's C1 down to W2, corresponding to the type of the structure. So concrete, reinforced masonry, steel, wood, and so on. I'm going to click on apply and OK. And now when I open this structural types layer and I visualize it, you'll see the different coloring according to the different type of structure. Now I'm going to join a new layer to all of this, or sorry, I'm going to add new data to this layers. And I'm going to go into the Pelican results. So I will show a spreadsheet now, a CSV file of the DV, so the decision variable data. And if I click through some of these headings, you'll see it's repair cost, aggregate mean, repair time, aggregate mean. So if I slowly go through them, there's repair time, repair cost, and injury. So there's a lot of information here. And each one of these rows corresponds to a building. And this is the component or building ID, which I will use to add all this data to these different buildings that I am visualizing right here. So I'm going to take this DV data CSV file and drag it right into this GIS window. And you'll see it appear here automatically in the tree on the left-hand side. So now I'm going to go to say this loss ratio layer. I'm going to create a duplicate of it. So loss ratio copy. I'll just call this the base layer, if you will. And to this base layer, I'm going to join it with this DV data. So first, I'm going to show you what information is there. If I click on identify, this identify results pane will pop up. And when I click on any one of these features or geometries, you'll see the information for that geometry appear here. So things such as the ID, the location, number of stories, and so on. Now, I'm going to go back here, double click on what I call the base layer. And I'll see the layer properties again. I'm going to go down to the join tab. So join. And then I'm going to click on the add button. And I want to join the layer called DV data with this layer that I'm currently on, which is the base layer. And I'm going to have to specify two fields with where I'm going to use as my reference point. So in this case, I'm going to use a component ID. And in the target field is going to be the same thing. So the building ID. I don't want a custom field name prefix, so I'll leave that blank. And that's it. I will just click OK. The join layer appears. I'm going to click apply. OK. and I want to make permanent. So that's going to save that. Now, when I click on one of these layers, so if I click on identify, you're going to see we have a lot more features, feature attributes that appear here. So repair cost, time, so on. All the things that were in this spreadsheet are now joined with this feature layer. And again, I could right click on the spreadsheet and go open attribute table. And it will allow me to visualize this data, the same thing that we saw in Excel. But now that I have that data here, I could do certain things with it. So I'm going to click on this layer again, and I'm going to go down a right click, and I go down to open attribute table, which will show me the table for this layer. So each one of these, each row is a building, and all the different attributes are up here on the top. Now I'm going to create a few new attributes. So I'm going to go the fourth button from the left. It's called Open Field Calculator. So I'm going to do that. And that's going to bring up my field calculator, and I'm going to create a new field called repair time. And that's going to be a decimal. And for that value, I'm just going to use the existing field. So I'm going to click here on fields and values, and I'm going to go down to repair time, and I'm going to use the mean. So the aggregate mean repair time for each building. I'm going to double click on that, and that's going to appear here. Now, this is an expression. I could multiply it by some scalar. I could divide it by another one of these fields. So you have a lot of power here to specify what will be done to this new field called repair time. I'm just going to take the value from repair time aggregate mean and set it this, and make sure the field type is a number. So I'm going to click OK. And that field should appear at the very end of the table. So that's good. And I'm going to do that one more time, but this time for the repair cost. Make sure it's a number. And I'm going to go to fields and values, and I'm going to find repair cost aggregate mean, double click on it, click OK. And if I go to the table, now you'll see repair cost. So that's good. And you'll see this little pencil here, which means that the layer was edited. And I'm going to go to save layer edits. And I'm going to toggle editing, so I don't want to edit that layer anymore. Now, if I click on one of these objects again, you'll see the repair time and the repair costs are here as well. I'm going to go to the GIS menu, the one I showed previously, and I'm going to select on pan map, so it doesn't select any features when I click on them, it just pans the map. Now I'm going to take this base layer and I'm going to duplicate it again. So I'm going to go duplicate, so right click, duplicate layer, right click, rename layer. And I'm going to rename this layer to repair time. And I'm going to double click on it and go back up to Symbology. And instead of the loss ratio, I'm going to go repair time. And instead of yellow to red, I'm going to select, say, white, a whitish color. Let's do white. It's going to go from white to red. Okay. And we're going to have to click on classify, which is down here. And then you'll see all the different values. So it goes from about 3 days of repair to about 114. You can also create a histogram if you wish by clicking on this histogram tab and clicking on load values. And you see the distribution of the repair time. I'm going to go back here to classes and then click on apply and OK. And I'm going to turn off this base layer and turn on repair time. And now you see the distribution of repair time throughout the city. And you see it's kind of concentrated a little more down in this region. I will also duplicate this layer one more time, the base layer. And this time, I'm going to rename it to repair cost. Now, again, I'm going to double click on it. It's going to open up this layer properties. I have it as graduated one more time, but I'm going to do something a little different now. If I click on symbol, the symbol settings dialog will appear, and you'll see I have a fill symbol. So all it does is it fills a polygon with some color. I will change the symbol layer type if I go here to this dropdown called symbol layer type, and I'm going to do a centroid fill, which essentially means in that polygon, in the centroid, is just going to be a marker. So if I click OK, and then I click on apply, and I want to visualize, I'm going to click OK, and I want to see what's going on. So I'm going to turn on repair cost, and now I see the repair cost points at the center of each polygon. I will double click again, open this up, and instead of the loss ratio, now I want to go to repair cost, and instead of yellow to red, we will go say white to some type of blue here. And we'll classify again, and now you see the different repair cost values from something very negligible to millions of dollars. And now I'm gonna change how this dot looks. So if I go now to apply, you see these dots have changed color. It's hard to see. Actually, I will have to not use pretty breaks. I'm sorry. I'm going to have to go to equal count and then classify. There seems to be a problem with how the pretty breaks show up. So now you can see there's a difference in color from white all the way to blue. And now I want to visualize the uncertainty. So all of these points or dots, if you will, are the same size. They're just different color. But I want to see how uncertain are these values. So what I'm going to do is I'm going to click on the symbol, click down here where it says simple marker, and then you'll see a parameter called size. So I'm going to click on this button here called data define override. And I'm going to go down to this edit item. And that's going to open up something called expression string builder. Quite a long name. But what I want to do here is visualize a coefficient of variation for the repair cost. So I'm going to go down here to the fields and values. And I'm going to click on repair cost standard deviation. I'm going to divide that by the mean. And I'm going to scale it by a factor of 2, just so it's more visually, just so it stands out more visually. So as you see, this expression now here is 2 times the repair cost standard deviation divided by the mean. So essentially the COV, 2 times the COV. And I'm going to click on OK. And you'll see here now that this little expression symbol appeared right here. And then click on OK again. And click on apply. And OK. And I could visualize the bigger this dot, the more uncertainty you have. So the more variation there is around the mean. And the mean value is the color of the dot. And again, if you look at the legend here, you can see the corresponding values. And you can see that the darker dots are kind of clustered around where the longer repair time, which makes sense. Next, I'm going to show you how to filter. So we could, let's say, turn off repair cost and only look at repair time. The way we filter is we can right click on the layer that we want to filter first, and then go down to this filter item right here in about the middle. And when I click on that, it's going to ask me, you're about to filter a layer that has joined fields, and just click yes. And the query builder will show up now. So just like before, we can create a custom expression that we want to filter, that we want to use to filter this layer. So here I will use, say, the year built. So I'll say all the buildings. I can go here to year built, double click on it, and then it says less than 1970. So the building's built before 1970. And click on OK. And it will show me. So there's quite a bit of buildings here that are older. I could identify them. Built in 1938. Built in 1904. So there's quite a bit of old buildings here. I'm going to go back to the pan app. And you'll notice that this layer now has a filter. But if you look here on the layer tree, there's a little filter symbol right here. And I could double click on that again, and it'll show me my expression. And I could say Let's filter this one more time. So I can go 1950, less than year built. And now it's going to show me all buildings built between 1950 and 1970. So that would be these buildings. And then we can look at these and see, what are the repair costs, or sorry, repair time. And we could add, additional layers and filter them as well if we're interested in a certain subset. And these filters here are rules. So if you want to, again, categorize these layers, if I double click this layer again, I can go to a rule-based render, and you see essentially it already created rules for me. I could double click on that, and this is how that rule looks. And I could change this or create my own custom rules. I could say repair time greater than 3.54 and year built less than so on and so on, and then get these different rule-based visuals. I'm going to cancel that. And finally, you can export what you've created here. You can save it as a project to load again in QGIS, or you could just export the layer. So you do that by right-clicking on the layer you want to export and go down to the export selection. And you want to go save features as. That's going to bring up the save vector layer as window. And you have different formats. So in this case, I choose a GeoPackage. You can do a Esri shapefile, which you can later say upload to the Esri cloud to use in a web page, AutoCAD, and there's many other GIS formats here. And the idea is you could save your layer of your results and send it forward to another GIS program to view, because perhaps the person viewing it doesn't have R2D. They could have QGIS or ArcGIS or whatnot, or even an online GIS viewer of some sort, which they could load your layer and view the results. You can also go up to the GIS Map tab, click on Project, and then click on New Print Layout. And we'll just give it a name here, say Test. And that's going to bring up this window where we can create essentially a graphic for use in a manuscript or web page or documentation. I could add a map here. Click on Add a Map, put it here, and it's going to take whatever I see on my screen and render it here. In addition to that, I could add certain things like a scale bar. I can make it bigger. I can add the north arrow. And that sort of thing. So you could customize the map according to your needs. And you could add also sub maps. So if I want to create, say, something like this, I can go here again and click on Add a Map. And it will create something that looks like this, perhaps. And I could also add legends here. So pretty quickly you could create and you can go through here and remove the items you don't want. I won't waste time on that. But you can go through here and create a visual that's appealing for your type of, or how you want to display your data. Okay, and that's it. I'm going to go back now to the presentation. And don't miss these upcoming live expert tips. So on December 10th, we have calibrating OpenSea's material model using experimental data. And that's with my colleague, Dr. Akash Satish. And on December 17th, we have coupling regional scale tsunami simulation with local scale structural response. It's with Dr. AJ Harish. And this is using HydroUQ, and this is using QuillFem, which are other SimCenter tools. And to register, you can go down to this link at the bottom of the screen shown here. And any questions?